For this lesson on section 2.4 and 2.5, what I'm going to do is briefly walk through our notes handout that we gave you. Feel free to pause the video at any time, and if after listening to this video you feel you need more help, you can read the sections 2.4 and 2.5 in your textbook. So first of all, a linear function is something that looks like a line. We studied these quite a bit in Algebra 1 and Geometry. The format that you're probably used to seeing is y equals mx plus b, and this is the same as f of x equals mx plus b. In this equation, y is a function of x, and we'll talk more about functions in the next week. As far as the domain and the range, domain are all of the allowed x values for the function, and the range is all of the allowed y values for the function. Because this equation can use any x values and any y values, both the domain and the range is considered negative infinity to infinity. Now when we look at graphing lines, there's several situations to look at. We have our basic line that's in slope-intercept form, like we see in part A, and in this case you'll identify the y-intercept to be -2, you'll put a point at -2, and then to get your slope, you'll go up 3 and over 1, up 3 and over 1. You need to plot 3 points on our graph, and you need to plot integer coordinates. For part B, this equation you can either you can either solve for y or you can graph using intercepts. When we solve for y, we subtract the 3x over and then divide everything by 15 to get the equation y equals -1/5 x plus 3. We start at 3 on the y-axis, and then because this slope is negative, we go down 1 over 5. Now I can't fit another point in the right direction, so instead I reverse the slope, and I go up 1 and left 5. If I would have solved this equation for my x and y intercepts, the point where x is 0 or y is 0, the x-intercept will not fit on my grid, so this method is not really going to help me here. In part C and D, we see an example of our horizontal and our vertical line. A vertical line is not a function. It will always be in the format of x equals a number, and to graph, you put a point on the x-axis and then draw a vertical line through it. A horizontal line will always be of the form y equals a number, or it'll be a constant function, in this case f of x equals -2 and always equals -2. We'll put a point on the y-axis at the y value of -2 and draw a horizontal line through it. If you flip on to the back of the page, we'll see one more graphing example where we're given a point and a slope. So to graph that, we just start at the point 3, -5, and then we do the slope of 2/3 from there, up 2, right 3, up 2, right 3. When we want to find the slope, there's several ways we can do this. So first of all, slope is abbreviated with an m, and it is described as the rise over run of a graph. We also will describe slope using the triangle y, which stands for delta, or change in y over change in x. And that can be found by subtracting the y values and then subtracting the x values. Now, the order of which you use the points for subtraction doesn't matter. You can do first point minus second point, or the second point minus the first point, as long as you remain consistent. Oh, that's annoying. If you are given a graph, you can either get 2 points and then use slope formula, or you can count squares. Just remember that a positive slope goes up to the right and a negative slope goes down to the right. In these examples below, you'll see that I have calculated the slope in each case. In part A, I get 8 over -4. If you subtracted the points in the other direction, you would have gotten -8 over +4. Either way, this still reduces to -2. All answers must be simplified. So if we look at part C, you cannot leave it as negative over negative. You must simplify. The fraction must be reduced. In parts B and D, we can see our 0 and undefined slope. If the 0 is in the numerator, then the slope is 0. If the 0 is underneath, then it is undefined. HOIVUX is an acronym that many people use to help students remember horizontal and vertical lines, and what it stands for is horizontal lines have a 0 slope and a y equals equation. Vertical lines have a vertical slope, an undefined slope, and an x equals equation. And then lastly, if we're trying to find slope by looking at a graph, we'll just count squares. In part E, I went up 3 and right 5. Now for the second page of the handout, This is on section 2.5, which is equation writing. You'll see at the top the three basic equations you'll be expected to know. The first one, slope-intercept form, is the one that students are most familiar with. Point-slope form is a great equation that we can use as a starting point to write an equation, and standard form is often a way that we will finish the problem. With standard form, you need to make sure you clear any fractions so that a, b, and c are integers, that x and y are on the same side, and that a is positive. Read over the examples 1, 2, 3, and then try examples on the back. The correct answers are listed at the bottom. If you did not get any correct, then I'm going to go ahead and walk through them. If you got them correct, then you're done with the notes and have a great weekend. Looking at example 1, we give you 2 points here. So we'll do slope formula to find our slope equals 2 over negative 3. Now when I go to plug this in point slope, I can use either point. I chose the first point. You could have also chose the second point. Since I want my answer to be in slope-intercept form, we will distribute, add the 6 over, and then we can have our equation in slope-intercept. In questions 2 and 3, we want you to find the equation of a line parallel to the given line or perpendicular to the given line. Now when we're parallel, we're going to have the same slope. So the first thing I do here is find that the slope of my given line is equal to negative 2. So now I use that slope negative 2 along with the point 3, negative 7 to put my problem into point slope form, distribute, and then at this point I need to get x and y on the same side with a positive x and no fractions. In the last example, we want to get the slope, so again we solve for y on our equation, find the slope of the given line is 3/5, therefore the perpendicular slope is negative 5/3. I use this point together with point slope form, distribute, solve for y to get slope-intercept, and then multiply everything by 3 and add the 5x over to get standard form. Alright, that's it with the notes. Hope you have a great weekend, and we'll talk more about this on Tuesday.